afternoon, everyone. Hello, GHCI. How is everyone doing today? Great. How's the energy on the floor? Okay, that's cool. So we all say that AI is the one that is the most, that's taking the center stage, that's taking the mainstream conversation. And, we all are running in the, or living in the AI age. And it is going to take our imagination far and beyond. But what is more important is that how do we interpret the AI? How do we think of it as a student? If we have to take it as an analogy of the student, it's one of the most brilliant student. AI is considered as the most brilliant student with limitless potential, taught by multitude of invisible teachers. Now, some of these teachers teach it fact, some of them teach it some nonsense or chaos, and some of us teach it biases, stereotyping, hallucinations, and then it's all unintentional. And then, when we sit back and look at the AI results, we all actually think that why is it hallucinating? What's the reason that why is it hallucinating? Why is it misaligned? Why is it misguiding us? Hello, GHCI. This is Aparna, and I'm here to talk about one of the most conventional issues that lies much, much, much deeper. It's an honor for me to be here, standing in front of you in this room full of technocrats, designers, architects, system thinkers, trust engineers, who are going to define the next era of intelligence. But then, when we talk about the next era of intelligence, one thing that holds a lot of importance is it's not GPU cluster, for sure. It's not model size. It's not algorithms that I'm going to talk about. But I'm going to talk about something which is far more consequential, something that we think to overlook at it many times. It sits much beneath the AI surface, and it's more about AI governance. The future of AI, or the future of intelligence, will not be won by people who are, it will not be won by organizations who are having the biggest model, or who have the fastest inference, or even who have the fastest GPU clusters. Rather, it will be won by the people who who engineer the intelligence intentionally, deliberately. With me so far? Okay, let me move on to the next slide. Okay, so that's where we are going to talk about, from chaos to Codex, why AI needs data as code. Data as code is the design principle for the entire intelligence lifecycle. It is not just a paradigm shift, it's a cultural shift that we all need to look forward to, because it could be one of the biggest transformation of the AI era. Let me tell you a story, right? How many of you, or how many of us have gone through our kitchen? Come on, everyone, right? Kitchen is something, and that's why I have picked up this particular story. Now, think of a kitchen. You are stepping into a kitchen, which is where chaos are like humming like a background noise, where jars are unlabeled, ingredients are all scattered through the floor. Everyone seems to be busy, but no one is aligned. When the recipe, the dish comes to your desk, to your table, it could be a disaster, or sometimes it could be a magic as well. That's the chaotic one. And then we also have a Michelin star kitchen. In the Michelin star kitchen, the light itself is different. It's calm, it's deliberate, it's disciplined. The jars are labeled, every tool has a room, everything finds its own place, and everything looks so very organized. So every organization today is either cooking with chaos or crafting intelligence with intention. And that's the beauty of it. If you see this left-hand side image, this particular image, everyone seems to be busy, isn't it? Everyone is super occupied with preparing something. But then, no one is aligned there. The jars are unlabeled, the ingredients are all scattered, the recipes are not documented, not versioned, not audited. There's no guarantee, there's no predictability that the same taste that you got today, it will be the same taste that you will be getting tomorrow as well. And trust me, most of the AI teams who are building AI, who are working in the organization, are in this particular state of the kitchen. And then you see the Michelin star kitchen. What is different here? The kitchen that you see on towards your right, this is the state that each of the organization or each of the teams that are building AI want to be in. But the data state is something which is matching this particular kitchen. Here the light itself is different. Every recipe is documented, versioned, committed, audited, so that the results, the output, the recipe, the dish that you prepare is very much predictable. It will be the same taste that you are going to get the next time. So, what's the mantra here? It's more about, it's not just about, organization managing the data or something. It's more about how the organizations are versioning the data. Because AI, we all know that, whatever you feed in, it actually feeds, you get out, garbage in, garbage out. So if you're going to feed in the good data, it is version data, audited data, committed data, the drift detected data, it is going to give you something which is much more meaningful, which is much more insightful. But the moment you miss these governance steps out there, it is going to give you a chaotic dish, which is kind of unpredictable and not versioned. How many of you are facing the data problem these days? How many of you think that models are very much deterministic? Every time it will give me the same data. Or how many of you spend time in understanding what this data is about? Why is it using? Or is this data outdated? Or what about the observability or the timeliness or the freshness of the data? We are talking about artificial intelligence. Artificial intelligence has taken the boardroom and the main room conversations. And then when we talk about AI, probably the most important thing that we don't talk about is the data and the governance aspect that governs this data, which is where the paradigm shift, the cultural shift that we need to talk about is that treat data as code. Commit it, version it, all the schema changes that you are making in the data, all the pipeline changes that you're making in the data should be governed, should be audited, should be documented somewhere. Every transformation, every schema lineage needs to be documented. Okay, let's look at some numbers. Let's look at the reality check. So the kitchen metaphor could be, it could be a really simple story. It could be a metaphor, but the lesson that it gives us something very real. When you build with intention, be it a dish or AI, it actually gives you very good results. It gives you results that you can trust on, that you can rely on. But when you just, do some kind of guesswork, the lineage disappears. When you override clarity with chaos, your predictability disappears. And when we step out of the kitchen, let's do a quick reality check. And that's where we see that AI is everywhere, but the trust is not. Looking at the numbers, so KPMG said, a report by KPMG says that 66% of people globally use AI regularly. What does it mean? 2/3 of this world is using AI regularly. AI is sitting in your pockets, it's sitting in your workplaces, it's sitting in your workflow, it's sitting in your day-to-day decision making. But here's a plot twist. Only 46% of people say that they trust it. How should we translate it? That half of the planet, of the people who are using AI, are not even sure whether they are using the right system or not. McKinsey says that 72% of companies now use AI in at least one business function, which is slightly up from 55% a year before. That's a huge number if you see, like 55% up from year before. And even in the next 3 years, 92% of companies plan to increase their AI investment. But then, only 1% of leaders call their companies mature on the deployment spectrum. So if you see, AI adoption has been accelerating unprecedentedly. But then what is missing is the maturity, the capability with which AI should be trusted, the AI should be built, with which the data beneath that is going to form the foundation. Let's also look, the cost that is staggering. These are the numbers that are from IBM that says that 2024, the global average cost of a data breach hit 4.88 million. And in 2025, it was slightly down, but then it is still a cost of running a small hospital. Imagine one data breach cost us this much of money. In India alone, a single breach costs 220 million on an average. And then 1 in 4 companies globally have suffered a data breach. What do these numbers tell us? These numbers tell us that because we are not focusing on we are not inspecting enough the foundation of the artificial intelligence, the one that is very much fractured, very much siloed, not governed, lot of semantic ambiguities available over there, which is where we are facing these many problems. So where it all leads us to? It leads us to the trust crisis. We have the model, we have the GPU clusters, we have the AI capabilities, the algorithms and everything, but then what we don't have, the data beneath it, not just the data, but how part of it. Are we versioning it? Are we committing it? Are we inspecting it? Are we auditing it? Are we actually understanding the drift mechanism over there? There are multiple kind of drifts when we talk about, there is data drift, there is semantic drift, there is model drift, but when we talk about, we all talk about prompt engineering wizardry, we all also talk about the model size and the algorithms, which algorithm to use, but how many of us actually pay a lot of attention to why are we using, has that data changed? You all go to doctors, right? And doctor asks you to get some kind of medical test done. You go to a pathologist and you get your blood test and everything done. After 2 days, you again go to another doctor and the doctor again asks you to get the test done. How many of you have gone through this problem? And it feels very weird, right? Why the doctor is asking me to go again to for a medical check? It's costly and, why should I get my parameters again tested? I checked it just 2 days back. Because it's the timeliness of the data that matters. It's a vitals. It could have changed in the last 48 hours. And that's where, that's one of the most simple example. We all feel irritated. Yeah, 2 days before I got it done. Why do I have to get it done again? Because if the doctor prescribes you some medicine based on the old data, just imagine what happens with your health. And that's where the trust crisis comes in picture. We don't have an AI problem, we have the trust crisis. And let's also look at what actually puts up the trust crisis. It's about misalignment, ambiguity, and the governance gaps. It all starts from the fragmented solution. This is all where it starts. Organizations who work with the siloed data sets, fragmented data sets, inconsistent formats, and even multiple versions of truth. Not a SSOT, but MVOT. That is your multiple versions of truth instead of a single source of truth. There is no shared data lineage where the data is coming from, who has modified it when, for what reasons, or there is no unified or single source of truth for the data. That's where it all comes over there. So this is the fragmented foundation, which is actually the core issue for your AI trust crisis or the governance crisis. Next comes your governance as guesswork. This is all about broken governance. It's reactive. It's very much reactive. Policies are there in some PDF. You all might have, done some kind of regulatory test and put it in some kind of PDF. But then how many times does it get executed, or who executes it? Privacy, residency, and access rules apply with whom you ask. If you're asking someone very knowledgeable, maybe the person who is going to tell you the most information. But then, does it tie to a given context, your given domain? Probably not. The next one is the semantic chaos. This is where the semantic ambiguity lies. For the finance department, the definition of a customer could be different. For the marketing department, the definition of a customer could be different. And same with the HR. So there needs to be a shared definition, shared dictionary, shared glossary about what does this particular term mean, or what does this particular definition mean in terms of the data or the AI ecosystem. Different teams using different definitions for the same concepts. AI inherits human ambiguity, unfair or unstable predictions, leading to more trust crisis. The next one is invisible intelligence. The next one, what we are going to talk about is we build models on top of this, right? So there is fragmented foundations, governance, broken governance, semantic ambiguity, and then there is invisible intelligence. It means that there is no monitoring mechanism for the model drift. Please go and read about drift. It's a very important concept and very important phenomena that is taking the center stage. There is very minimal bias monitoring and very less explainability for the model, which means that today if it's like a black box reader. It's giving you the prediction, but you're not going to, it's not able to tell you back that, okay, why did it give you this particular prediction? There's no reasoning out there. It's more about a black box decision-making process, which erodes trust and also, it creates a lot of friction over there. And then the last layer is about the synergy between human and AI. This is where we as human beings, we talk a lot about responsible AI. We talk about human-in-the-loop components and all, right? But are we actually able to trust the AI? And yesterday I was in a leadership discussion and we were discussing about, are we able to trust AI? And that's when I thought technologies to drive a pilotless plane existed a decade before as well. Isn't it? Technology to drive a driverless car exists even now. But how many of us feel comfortable sitting in that car and driving back home in this particular Bangalore, traffic? None. Will you be comfortable? We all need, Uber, Ola, and everything. But what if, Uber guys and Ola guys start telling you that, okay, hey guys, let's have a driverless fleet of cars? How many of you will feel comfortable? It's all AI, it's all fast, it's all trained on billions of parameters. Will anyone of you be comfortable sitting in that car or plane? No, I'll also not be comfortable. So this is, if you actually stack all these layers up, it will tell you that, the fracture, the fragmentation, the misgovernance lies at every layer. And when we fix these 5 layers, we are going to move from code to codex. And we'll see how. I had a very beautiful case study as well, but due to the paucity of time, probably I'll just limit my thoughts to the framework that I'm going to talk about. So what's missing? The missing piece is not another model. So many of us think that, okay, now this is a problem. Shall we build another model to fix this thing? Shall we build a bigger model to fix this thing? Or a smarter model to fix this thing? But the solution is simple. We need governance, we need data, we need more audit, we need more observability of the data, more catalog, more metadata oriented. And that's where, metadata engineering is emerging as one of the more sought after discipline. Trust engineers, metadata engineers, the people who are able to govern the data, and AI ethicists. So the core idea is data as code. That is more about when we build data as code, it is more about we are building intelligence with intention. Otherwise, it will be all accidental intelligence. That yes, we are getting something today, but there is no guarantee that we are going to get it tomorrow as well. And mind you, if something goes wrong, come on, it's not my responsibility, you take the ownership. So data as code is intelligence with intention. Most of the companies have the data that we look at here, but we need to codify that data. When we codify it, what do we mean? That as software engineers, when we do versioning of the data, we do the commit of the data, we do the schema tracking of the data, we capture the lineage of the data, right? So similarly, we have to do everything. Every transformation has to be coded. Every pipeline has to be coded in terms of the data engineering. And that's where we come from data to code to the intelligence. And that's when we will be able to drive the meaningful intelligence, which means that data is treated with software-grade discipline as a first-class citizen when we are building AI models. It should be version-tested, observable. It should be governed through logic, not checklist. With me so far? Okay, I'll just go back 1 second. Okay, so I'm going to introduce the Codex intelligence framework. This is the shift from accidental to intentional intelligence. where everything can be, documented, coded, versioned, and everything. Turn scattered data into your structured intelligence. The very fundamental layer is the bedrock layer. It is where the intelligence plumbing starts, the data plumbing and the intelligence plumbing starts. So where data stops being a data swamp and becomes an engineered terrain. We all are aware, right, what a data swamp is. Data lake, data swamp, we all might be aware, right? Or if not, you might want to go and, have a look at it. So this is the layer where we are going to codify each of the pipeline that we are having, and such that the data stops being a swamp, fractured one, and then becomes an engineered domain, intentional, very much intentional. The layer that gives AI something solid, traceable, testable, and reproducible to stand on. The next one is the governance layer. We talked about the broken governance. Here we are going to address the governance issues over here, wherein the rules stop living in PDFs and instead it becomes executable in the pipelines. Compliance becomes an automatic reflex of the system, not as an afterthought, but a forethought of it. Because what happened in the chaotic kitchen, if we have to just revise that kind of analogy, there actually the data is stitched in the night and governance is generally a frantic afterthought. What we are suggesting here is that, if we are going to build the governance as an executable layer, it is going to run with each and every pipeline, each and every transformation that you are building to build your AI model. The next one is the semantic layer. So this is the meaning, right? The data meaning that we are having. So meaning becomes machine readable, universal. There is a shared glossary. There is a version control. If there is a drift in the semantic aspect of it, it is properly documented, audited, validated, and then it flows through the system. Intelligence should flow through the system. We shouldn't fight for it. OK, no, this is the meaning of this particular thing. And it's also, the semantic layer is also about, not speaking multiple dialects. It's just about speaking a single dialect so that we all understand the same thought process. The next one is the insight layer, and then above that is the synergy layer. When we talk about the insight layer, this is the one where, it is able to reason that why did it do so? What was the rationale behind it doing so? And then in the human synergy layer, there has to be human in the loop component, responsible AI, AI ethicist, AI governance, everything actually, amalgamates here. So if we as humans are treating AI as partners, it is only going to amplify our overall work. But if we are going to just think about it as a replacement, it's just going to degrade the work quality. Moving on. We'll just quickly go through how to achieve this thing. So there were 5 layers. There were 5 level of issues that we saw. There are 5 layers of solution that we are going to look at. This is the bedrock layer. How do we do this thing? The goal here is to build the infrastructure where the data lineage, the quality, as well as the transformations are natively version controlled as well as observable. Data observability becomes the key here. And which is where you also need to train your engineers that, OK, treat data as well as a software code. Key interventions include adopting declarative data pipeline instead of just using SQL coding aspect, use DBT or data form or data live tables to have the declarative data framework. Then is the implement data ops workflows, build the CDCI pipelines. Every schema change, every validation, every transformation must pass through the automated test. The unit testing for the data needs to be pretty much over there. Then is the introduce data contract. This is more about defining explicit machine verifiable agreements between producers and consumers of the data. How the data is going to be shared. How many of you have read data card or know about data card or the model card? Lovely, that's great. So data card is something, we will go through it in the later section, but data card is something that's a single source of truth for all the data. It's just not a documentation. If you look at the data card, it's like the nutrition label, right? You see a bottle of jam or any pickle or something. It has a nutrition label attached to it. So data card is the similar thing for the data set that we are using to build the AI models. And similarly, we have the model card that also acts as a nutrition label. Why, how, who owns the data, who owns the model, why is it being used. It's like a business model canvas that we have for, for any kind of product proposal. So there are certain pros and cons to it. Of course, anything comes with a trade-off as well. In terms of pros, it does improve the stability, reproducibility, observability, auditability, and other such stuffs. But initially, you might feel a slower velocity while implementing it. It also requires reskilling your engineers. So you can plan that, which domains you want to, tackle first in terms of your strategic balance. So begin with the high-impact data domains, start small, and then move ahead accordingly. The next one is the governance layer, where we are going to move from the manual reactive governance more to automated executable compliance and trust frameworks. And this is where the key interpretations include defining governance rules as machine-readable processes, as well as integrating lineage-aware governance, and then automating audits. Some of the pros that you see here is it does help in scaling compliance, because every time manual compliance check is not possible. It also prevents any kind of policy violations. Many of the organizations spend a lot of money in terms of after check or policy audit and regulation check and everything. It also enables AI explainability. But what is also needs to be taken care of is that it requires deep metadata maturity. With the data cataloging, with the deep metadata maturity, we need to understand that where, how, and what is the kind of data that we are leveraging. And that's where we need specific skill sets pertaining to the metadata engineers, who are able to classify, understand, catalog, govern, and then have the AI-ready data in terms of the preparing of the AI model. And then start by codifying the most business-critical priorities. So you don't need to codify each and every policy. Start off with the PII, start off with the masking. This is the most easiest one to do, and then proceed it accordingly. The next one is the semantic layer, the semantic ambiguity. This is meaning that treat data as a first-class citizen. This is more about establishing a shared machine-readable format such that it's more about a glossary. We need the domain experts. So earlier, there were dedicated teams which used to do specific functions. But now we need dedicated teams who are able to collaborate and then develop something which is more meaningful through information sharing, knowledge collaboration, design discussions, and systems engineering accordingly. And which is where we need the semantic layer, which means that treat the data as a first-class citizen. The key interventions could include here, building ontologies using knowledge graph, or even on the semantic layer. Then enforce semantic versioning. Today, the meaning referred to this, but in this fast-changing environment, so earlier, LIT was, something was like light, lit, the second form, right? But now the Gen Z or the Alpha Gen, they say this idea is a lit. So the meanings change. So have the semantic versioning over there. Use data-driven data observability to track this. There are pros and cons in terms of it enables explainability, but the cost is also, high upfront design effort as well as cultural resistance you might encounter in your team. So the good balance that comes is that begin with a few core entities where inconsistent meaning is, taking a lot of time and a lot of eroding your trust. The next two layers is about the intelligence layer. This is about AI observability and the trust engineering. Make AI systems explainable. This is where you need to integrate the responsible AI principles. Responsible AI principles talk about transparency, ethics, fairness, as well as accountability, so explainability. So all these are captured through different kind of matrix. So start, building all these kind of things over there so that we know that what it is actually talking about. And as humans, what are we actually deciphering about it? You can link model inputs to version data sets for the traceability aspect. You can build data cards and model cards. Data card and model card so data card was defined by Google. And there's a very good paper, very good data card playbook. It's available in the public domain. Please go ahead and read it. And embed trust matrix. So that is, come up with a trust matrix that suit your domain and the organization that you're working in, and then try to embed it. Some of the pros and cons that you see here, it enables regulatory readiness in terms of Responsible AI or DPDP Act that India has recently passed. And then cons is, you could observe, some of the system overhead as well, but then it also requires a lot of cross-team ownership and clarity. Yeah? The next, so this is a data card. These are the 2 links with the data card. I think the presentation would be shared with all of you. It's very much available in the public domain, so you might want to just leverage it. Then we also have model card. I just wanted to show you how a model card looks like. This is how a model card looks like for a given AI model. So it actually tells you the model details, what are the intended use, factors, metrics, ethical considerations, who is going to use it, what is the evaluation data, and what is the training data, what are the sources of that data that was particularly used. So treat it as a nutrition label, treat it as a single source of truth for the model that you are building for any kind of audit purpose. And every time it is changed, the data underneath is changed, start using it, leverage it. This is another example for the model card. So next we have the human-centric layer that is more about AI-human collaboration systems. This is more about building the data ecosystems where humans collaborate with AI and get their results amplified instead of just replacing it. The key interventions are more about conversational data governance, AI-assisted pipeline authoring, ethics as feedback loops. I'll give you a very quick example. I know I'm just running out of time, but I'll give you a very quick example. If you see COVID, right? COVID struck all of us on 20th of, sorry, the COVID lockdown actually came on 20th of March or something, right? So all the AI models that were working very well till 19th of March 2020 stopped working right after that. The moment lockdown actually kicked in, all the recommendation systems on Amazon based on your past shopping behavior or your the supply chain metrics and everything stopped working because the underlying assumptions of the model changed. The data that was required to train the model for the given scenario has to be different. So that is the kind of repercussions. It's not just about building the models. It is more about investing in the how part of the data, the underlying assumptions that we are using to train a specific model to build a more predictable and more governed system. I'll also go through some kind of trade-offs. There is speed versus discipline. Of course, we all want to move on faster, but then we also require discipline that might slow down your system. So we need to understand that where to pause and where to actually go ahead onto that. Then there is standardization versus innovation, wherein it actually gives us the risk of rigidity, but then with the standardization there is a lot of consistent semantics, and we start treating the schemas as living entities with the semantic versioning out there. Then there is automation versus oversight. We all love to do automation, but then at the same time we need to understand that we need to build the trust in these AI pipelines such that it does not erode the trust. Centralization versus autonomy, how much control do we need to give? Do we need to automate everything? Do we need to provide full control to the AI models, or there has to be centralization governance model? We need to figure out that. And then we have openness versus privacy aspect of it. Cool, so I have a few more things, but then maybe I'll leave it due to the paucity of time. All I want to say towards the end of the session is that intentionality is the new competitive advantage, and moving from chaos to Codex is a choice. It's not something that it will come deliberately. It's a design principle that stitches the entire intelligence pipeline. So which is where it's very important that we treat data as code to build more sustainable, more reliable, and more trustworthy AI. On that note, thank you so much. I'm available for question and answers after this.